All right, so again, what are fractions? Fractions are parts of the whole. If you have 2 parts, 8 slices, if I eat 2 out of 8, that's 2/8. If I have 6 slices total and I eat 4 of them, then I have 4 out of 6. All right. The top of a fraction is called numerator. The bottom fraction is called a denominator. And the way I remember that is the denominator is down. So the denominator is on the bottom. D is for denominator, D is for down, the denominator is on the bottom. That's how I remember it. All right. You can see here some more pictorial representations of fractions. So if you look at the first one, we've got 1 out of 1, 2, 3. We've got 1, 2, 3, 4, 5, 6, 7 out of 8 total. 1 out of 2, 1 out of 4, 4 out of 5. And another pictorial representation of it, we have a numerator on top, denominator on bottom, the whole thing called a fraction, and there's a line that goes in between. We don't have a name for it. It's just there. All right? And I will sometimes refer to it as numerator and denominator, and sometimes I'll refer to it as top and bottom as shorthand. But you do need to be familiar with the terms numerator and denominator. All right, and I will sometimes I'll abbreviate it as NUM and DEN, which you can see right here. So NUM refers to numerator and DEN refers to denominator. All right, there are essentially 3 different types of fractions. Fractions can either be proper fractions, where the number on top is smaller than the number on bottom. So 1 over 2, 3 over 4, 5 over 6. The number on top is smaller than the number on the bottom. All right. Improper fractions. The number on the bottom, the number on top is bigger than the number on bottom. Or you can say the number on the bottom is bigger than the number is smaller than the number on top. So you see comparatively, I have a 3 over a 2. This number is bigger because the number on top is bigger. It's called an improper fraction. All right, and then you have what's called a mixed fraction, or we call it a mixed number. A mixed number or a mixed fraction is a combination of a whole number like that and a fraction. So 1 and 1/2, 2 and 3/4, 5 and 5/6. Again, those are just 3 different kinds of fractions that we see in mathematics. And that's going to be important to talk about in the future. All right. We're going to go back over this, simplifying fractions, aka reducing to lowest terms. When we say put something in lowest terms, what we mean is simplify the fraction. All right, again, a fraction has 2 parts, a numerator and a denominator. Simplify a fraction. So if we want to simplify a fraction, basically what you do is you divide by the same number on top and bottom. And then you keep doing that until you can't do that anymore. So here's some rules that we kind of know about already with math that will help us. And this will also help you with doing factor trees as well. All right, here's some rules. Rule number 1. Let's say we get an even number, like 2, 4, 6, 8, 10, 12, 14, 16, 18. The first thing we know about that number is, if nothing else, we know that we can divide that by 2. So if we ever get a number like 346, and we're totally stumped about where to start, we know that 346 is an even number. So at the very least, before we know anything else, we know that we can divide that by 2. All right, so if we just get stuck, if we get two even numbers, we're like, I don't know what to do with these numbers, I can divide by 2. All right, numbers that end in 0 or 5, 5, 10, 15, 20, 25, 30, 35, 40, can all be divided by 5. So if I ever get stuck, and I'm like, well, I got 30 over 35, what can I divide both of these by? Well, I can at least do 5. All right, numbers that end in 0 can be divided by 10. And last but not least, if I look at numbers who digit add to a multiple of 3, so this is a little more tricky, but let's take something like 3 and 6. That's easy. 3 and 6 are both divided by 3. 3 goes into 3, 3 goes into 6. We already know that. But what about 12? So 12, if I add the digits together, so 1 plus 2. 1 plus 2 gives me 3. 3 goes into 3. That means that 12 is divisible by 3. Or if I add the digits to, let's say, 72. 7 plus 2 is 9. 3 goes into 9. That means that 72 is divisible by 3. And I can do that for just about anything. For example, let's say I have 1,224. So I have 1,224. Okay, 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 4 is 9. So if I add the 1 plus 2 plus 2 plus 4 all together, it gives me 9. 3 goes into 9, which means 3 goes into 1,224. So that's one's a little more tricky, but if you can learn that one, it's also helpful. All right, so based on that, if I have the number 25, and you can put the answers in chat, what number can I say, without having to do any work, goes into that number? That's a real question. 25. What number can I say without having to do any work goes into 25 without having to do any work? Good. 5. $40. So based on the rules I just gave, what's at least one number that can go into 40 without having to do any work at all? All right. So at least 2, 5, and 10. Right? It's an even number. It ends in a 5, or ends in a 0, which means 5 goes into it. And it ends in a 0, which means 10 goes into it, at the very least. Annotations. All right. Cool. 16. Well, you know 2 goes into that one. And 21, a little more tricky, but I can at least figure out that 2 plus 1 is equal to 3, and 3 goes into 3, therefore 3 goes into 21. And 147 works the same way. Again, I can go through it. I have a calculator. I can check all these. So 1 plus 4 is 5. 5 plus 7 is 12. 3 goes into 12. It works out. 3 goes into it. All right. So again, those are really helpful. Just know if you know your divisibility rules, you can kind of get some stuff. It makes it easier. Again, I'm trying to develop number sets. All right, multiplying fractions. Multiplying fraction is the easiest thing you can do with fractions. To multiply fractions together, all you have to do is multiply straight across. So if I have 3 over 10, 5 over 4, and 8 over 9, all I have to do is go straight across. That's it. 3 times 5 times 8, 10 times 4 times 9. Gives me 120 divided by 360. Now, I want to take that problem and illustrate how I would simplify it down as just one example. So, if I wanted to break down 120 divided by 360 into its smaller parts, the first thing I would do is I would say, okay, what goes to both 120 and 360? All right. Well, they both end in 0. So at the very least, without having to do any work, I can say that 10 goes into it. All right, and then that'll give me 12 divided by 36. All right, if I have 12 divided by 36, at the very least, I know 2 goes in both of those because they're both even numbers. This is even number, that's an even number. Without having to do any work, I know that 2 goes in both of those. So I get 6 divided by 18. And then I get 6 divided by 18. Now, I have 6 divided by 18 without having to do any work. I know that 2 goes into a 6, 2 goes into 18, because they're both even numbers. So 2 divided by 2. Stop share for a minute. So 2 divided by 2. I divide the same thing on the top and the bottom. I put the line there just because of the fraction. You don't have to put the line there. You put like that. Same thing. All right. And I get 3 divided by 9. Now I'm almost down to it. So let me just go put it here. If I have 3 divided by 9, I know 3 goes into that and goes into that. And I get 1 divided by 'So if you look at it, 120 divided by 360 can become 1 divided by 3, which you see in the slide, but that's basically the idea, is you go through and divide the same thing by the top and bottom, and you keep doing that until you can't do that anymore. At this point, 1 divided by 3, it can't do anything else with it. But all right, so multiplying is very easy. I'm not gonna do much on that. You'll practice that. It's super simple. Okay. So that's 3 problems that you need to work on. I have the answers on them. Those are the answers. You can go back through later and you can look at and figure out how to get those answers. If you don't get those answers, you need to ask questions about it later. So that's 3 problems that you need to work. All right. Dividing fractions is different. To divide fractions, and again, dividing fractions is not that complicated. What you're going to do is use what's called KCF, keep, change, flip. So if I have 3/4 divided by 2/7, what I'm going to do is I'm going to use keep, change, flip. I'm going to multiply by the reciprocal of the second, essentially, and I'll go back to that later. All right, keep, change, flip basically means you keep the first fraction the same. So the first fraction, 3/4, stays the same. Then you change. You change from division to multiplication. Then for the second fraction, you flip it. So instead of having a 2 on top and a 7 on bottom, you move the 7 to the top and the 2 to the bottom. So the 7 moves to the top, the 2 moves to the bottom, and then you flip it, essentially. Once you flip it, it's super duper easy, because all you have to do is just multiply. But again, how do you multiply? Well, multiplying is actually really, really easy. You just multiply the top numbers and the bottom numbers. So 3 times 7 is 21, 4 times 2 is 8. And this is called a reciprocal right here when you flip it, which I'll do that in a second. But dividing of fractions is super duper easy. All you have to do is keep, change, flip. Keep the first one, change to multiplication, flip the second one. Now all you have is a multiplication problem, which is really, really easy, because again, you just go straight across the top, multiply all the top numbers and the bottom numbers. Keep, change, flip. That's how you do it. Once you keep, change, flip it, you multiply like regular. All right. And those are 3 problems for you to look at. I have 3 problems there. 8/3 divided by 9/4, 2/3 divided by 5/11, and 10/12 divided by 8/7. I put answers down for all 3 of those, and you can look at those and work on those and make sure you get the right answers. All right. So this is coming back to what we just said. When we flip a number, when we flip any number, when you flip any number, you take what's called a reciprocal. It's called taking the reciprocal, basically. If I take the reciprocal of 2/3, in other words, if I flip 2/3, all I do is take the top number, move it to the bottom, take the bottom number, move it to the top. So 2/3 becomes 3/2. I also have listed on this slide what happens when you flip like a whole number, like 6, but we'll get to that later. But the simplest kind of reciprocal, we basically say if I have 2/3, it gets flipped to 3/2. And we'll talk some more about that when we get to the idea of opposite versus reciprocal stuff. But that's just what a reciprocal is. It's not a super complicated concept. All you have to do is just flip it over. That's what reciprocal means. When you flip a fraction, you get a reciprocal. All right. All right, adding, subtracting fractions. We'll come back to that. So let me go back real quick. And come back here. And let me just say this again, just to make sure. Multiplying fractions, all we do is go straight across. We don't have to do anything fancy. We don't have to change any numbers. All we have to do is just multiply straight across. 3 times 5 times 8. 10 times 4 times 9. It's super duper easy. You don't need to complicate it by trying to find a common denominator or anything like that. All you have to do is just go 3 times 5 times 8, 10 times 4 times 9. But you just multiply straight across. Very simple. Um, dividing fractions. It's very, very simple. All you have to do is use what's called keep, change, flip. You keep the first one, you change the second one, then you flip. You change the sign in the middle, you flip the second one. So 3 over 4 times 7 over 2. We keep the first one 3/4. We change the sign in the middle to a multiplication, and we flip the second one. 2/7 becomes 7/2. And then we just go straight across. All right? And then we say reciprocal. All right, so I assume we have that basic concept. It's not complicated. Yeah, it really isn't complicated to multiply and divide. You just have to if you just know the procedure. All right, cool. Okay. So now we're going to get to adding and subtracting fractions. One of the common mistakes that people make is they get 3/2 plus 4/3. This is why people don't like fractions. Part of it. Let me stop sharing for a minute. 3/4. Plus 2/3. Because this is what people want to do. If you say 3 plus 2, that's 5. If you say 4 plus 3, that's 7. I know what to do with 3 plus 2 and 4 plus 3. So what I want to do when I get 3 over 4 plus 4 over 3, the first thing I want to do, if I'm just thinking like a normal person, I say, oh, that's easy. Done. Except that's not how fractions work. It's not as simple as saying, oh, I'll just add the tops and add the bottoms. See, when we multiply, if I was multiplying this together, I would just say, that's easy. And multiplying is super easy because I can just go 3 times 2, 4 times 3, gotcha, boom. Addition is the same, right? No, it's wrong, it's different. When we add fractions together, we cannot simply go 3 plus 2, 4 plus 3. It won't work. There's a whole bunch of reasons why it won't work. But we cannot do that. It doesn't work. It means that we're going to have to actually take a few more steps to do it. So what we do is we use the idea, we want fractions that have the same bottom, but essentially are the same, or have the same quantity associated with them. And this is called equivalent fractions. So let's look at these two equivalent fractions. If I look at this fraction here, it's 1 over 2, 2 over 4, and 8 over 6. Now I want you to look at this picture here. If I look at this picture, this is telling me that these are the same quantity. But let's think about this in terms of a pizza pie. So you go to Pizza Hut and you get you get one of those small pizzas. And it has 4 slices. All right. If it has 4 slices and I eat 2 of them, how much did I eat of that pizza? Well, you don't have to be a rocket scientist to realize that I ate half of the pizza. And I'll write as a word, half. So if I eat 2 slices out of a 4-slice pizza, that's half the pizza. Well, half is just 1/2. In the same way, if I take a pizza and I split it into 16 slices, and someone eats 8 of them, they ate half the pizza. So 1/2, 2/4, and 8/16 are the exact same quantity. It's the exact same measurement. In fact, if I put in my calculator, 1 divided by 2, 2 divided by 4, and 8 divided by 16, I get the exact same number. And these are called equivalent fractions. So essentially, I could rewrite 1/2 as 2/4. Those are the same thing. Now, how do I do that? Well, let's go back to this. And when you practice this, you'll see this a little bit better, but I tried to show it to you visually so you could just see it without necessarily with the problem. So notice that 24/108, to make it into a smaller fraction that equals the exact same thing, all I have to do is divide both of the things by the same number. And then to make 12 divided by 54 into 6 divided by 27, all I have to do is divide by the same number, the number 2. And then to turn 6 divided by 27 into 2 divided by 9, which again is the same, they're equal to each other. I just divide by the same number on the top and the bottom. That's how I simplify a fraction. If I want to make an equivalent fraction, I use the same principle, only this time, instead of dividing by the fraction by the top and bottom, I multiply on the top and bottom. So, if I want to turn 1/2 into 2/4, all I have to do is multiply. 2 times 2 gives me 4. And 1 times 2 gives me 2. If I want to turn 1/2 into, let's say, 8/16, all I have to do is say 2 times 8 gives me 16. 1 times 8 gives me 8. So if I multiply the same number by the top and the bottom, I get what's called an equivalent fraction. So that's how we do it. That's how we get an equivalent fraction. Is we multiply the same number by the top and the bottom. So you can illustrate it right here. If I want to go from 1 over 2 to 60 over 120, I multiply the top and the bottom by 2. I multiply the top and the bottom by 3. I multiply the top and the bottom by 10. I multiply the same number on the top and the bottom, and that gives me what's called an equivalent fraction. If I punch 1 divided by 2 in my calculator, I get 0.5. If I punch 2 divided by 4 in my calculator, I get 0.5. If I punch 6 divided by 12 in my calculator, I get 0.5. If I punch 60 divided by 120 into my calculator, I get 0.5. So, because even though they look different, they are essentially the same, they essentially have the same value. Just like, going back to this thing we did before, I have that little personal pan pizza. So if I have that personal pan pizza, 4 slices, and I eat 2 out of 4 of those slices, so I eat 2 slices out of 4, that's the same as half. It's the same idea. So even though it looks different, I know that's half. Even though half looks like this, 2 over 4 is the same thing. All right. So now we need to figure out common denominator. So that is the first idea. We need to get an equivalent fraction. Now let's get a common denominator. All right. The simplest way to get a common denominator, if we want to get for 2 fractions, so let's go back to what we said before. In order to add or subtract 2 fractions, we need to find a common denominator. You cannot simply add the tops and the bottoms of the fractions. So let's go and let's look at this here. The simplest way to find a common denominator is to take the 2 bottom numbers and multiply them. So if I have a 5 at the bottom of one fraction and a 3 at the bottom of the other fraction. So here I got a 5 and a 3. The common denominator, or the CD, I'll call it, is 15. 5 times 3. If I have an 8 and a 4, the common denominator, the simplest way to find it is to multiply them together. 8 times 4 is 32. Now, 8 is also 1 if you are clever enough to know all your numbers and stuff and realize that 4 goes into 8, you can figure that out. But let's say you didn't want to overthink it. If you didn't want to have to think about it too hard, you could say 8 times 4 is 32 and get 32. Or if I have 6 and 14, what's the common denominator for that one? Well, 6 times 14 is 84. 42 is also an option, but let's say you were tired, you don't want to think that hard about it, then the easy way to figure out is to say 6 times 14 is 84. That's how we find a common denominator. We multiply the 2 bottom numbers together. All right. So the way we do this, the way we add fractions together, is we basically take the 2 numbers and we get a common denominator. The way we do that is make equivalent fractions. So the common denominator between 4 and 3 is 12. So now, let me do a stop share. Instead of us working this the wrong way, let's work it the right way. So, my first instinct might be to say 5 divided by 7, but that's incorrect. I know that now. So we're not going to do that anymore, because we know that's incorrect now. I need a common denominator. So my common denominator in this case is going to be 4 times 3 is 12. I know that now. So I have to get a 12 at the bottom of this one. So I'm going to times this by 3. I'm going to do the same thing at the top of that one. Because again, to get equivalent fraction, we have to multiply the same number by the top and the bottom. So if I multiply 3 here, I got to multiply a 3 right here. Now to get to get a 12 to the bottom of this one, I multiply this by a 4. 3 times 4 is 12. You do the same thing here. So work it out. So now I get 9 over 12. So 9 over 12. 3 times 3 is 9. 4 times 3 is 12. Plus 2 times 4 is 8 over 3 times 4 is 12. So 9 over 12 plus 8 over 12. Now, how do we add two fractions together? So let's go back to fractions together. So let's go, let's see that real quick. All right, so we have two regular fractions. The way we add two fractions together is we add the numerators. The numerators are the top numbers. Oh, okay, that's fine. And we get 17. And then we add, and we keep these the same. So that is there. And the problem I did was actually 3/4 plus 2/3. That one says 3/4 plus 1/3. So I did actually two different problems. But the idea is still the same. Cool. And this is called.
So when you have two bottom numbers that are the same figure.
Yep, move over. 12, 12, 12. All right, and this is called an improper fraction. Or not F. I know that because the number on top is bigger. Now, I realized I went really in depth with that, and it's kind of beating dead horse, but I'm trying to hammer in the concept. You got to have the same number on the bottom. Until you have the same number on the bottom, you cannot add those fractions together. Now, this is totally different than multiplying and dividing. Multiplying numbers is super duper easy. But when you add and subtract, you've got to get the same number on the bottom. You've got to have a common denominator to be able to add and subtract. All right, what's next? Nibs on. All right, subtracting is really similar. If you were subtracting, it would basically be the same concept. So I'm not going to go too much into that. But if you're subtracting, it's the same basic concept. You basically need to you'll subtract the top numbers instead of adding the top numbers. All right. This slide here summarizes what I just said. When you are adding and subtracting numbers, you have to have what's called a common denominator. The number on the bottom has to be the same. If it's not the same, you cannot add or subtract it. If, however, you are multiplying or dividing fractions, you don't have to have a common denominator. If you get a common denominator, you'll make the problem more complicated and bigger. The problem will become bloated. You don't want that. So when you're multiplying and dividing fractions, you don't need a common denominator. When you're adding or subtracting them, you do need a common denominator. Now, I haven't mentioned simplifying much. Simplifying is pretty straightforward. You keep dividing numbers from the top and bottom until you can't anymore. All right, again, equivalent fractions are basically just, it's the same quantity represented in different ways. So 2 out of 4 is the same as 1 out of 2, as half. It looks different. It's the exact same value. All right, if I want to find the common denominator for two different fractions, all I have to do is multiply the two bottom numbers together. So if I have a 3 and a 4, the common denominator is 12. All right, multiplying and dividing again. When you multiply, you go straight across. So if you go straight across. 2 times 4 is 8, 3 times 5 is 15. When I divide numbers, I do keep, change, flip. So I might say 1/2. So I'll keep the first one, change the sign of the second one to multiplication, and then flip the second one. And then become a multiplication problem, which is super duper easy. Go straight across. I think that is cool. So it's basically 9 o'clock. I think I've given you plenty to work on. Let me make a quick announcement before you leave. My first quick announcement is going to be, and I'm just repeating things. On Wednesday, be prepared to take a quiz on Wednesday. The format of that quiz I have not worked out quite yet, but be prepared to do a quiz on Wednesday. All right. On next Monday, my plan is to have a test. Again, the format of that test I haven't worked it out yet, but I plan to have a test next Monday. So, quiz on Wednesday, test on Monday, first test on Monday. It's going to cover everything that we have covered and another section that we're going to do tomorrow. And hopefully, I think we should be able to get through, yeah, we should be able to get through both sections tomorrow. All right. That's it for me. If you have any questions from the homework, just send me an email. When you send me questions from the homework if you're still listening.
Say that one more time.
When you send me questions in the homework, it's helpful to actually send me a picture of the problem. If I don't know what it looks like, I can't really do anything to help you. If you say I'm having a problem with question number 4, or if you say, I'm having an issue with question number 4 on X homework, then I can help you. But if you just say, I'm having a problem with the homework, I can't really help you. The other thing is technical issues. Again, I'm not a tech guru. Most of the time that they work themselves out, I can try to walk you through it, but I don't know how to answer most technical questions. So if it's not pulling up on your browser, or a pop-up issue or something like that, I don't really know how to answer that question. You can ask me, but I don't really know how to deal with the technical issues. But again, if you're having that problem, let me know, because that tells me, okay, well, you did try to do the homework, but you couldn't quite get in. All right. Again, I'll finish with the thing I started with, a quiz on Wednesday, and I'll give you information about that in the email, and a test on Monday. That's what we're planning. So, and I'll give you more details about that on Wednesday. All right. That's it. I'm gonna send you this. I'm gonna send you this recording. I'm gonna post this recording onto a YouTube channel, and then I will send you this PowerPoint. So you'll have both of those. So you'll have everything you need. I think that'll do.
Hey, is there any more homework that you've posted on My Labs?
I have. I posted a good bit of homework.
Okay.
Some of it we haven't done yet, but some of it we have. But you'll see. All right. That's it. That's all I got. I'm gonna go ahead and unless someone has a question that they want to ask, I'm gonna go ahead and end the meeting. Does anyone have a question beforehand? Before I end the meeting, does anyone have a question? You can put it in chat if it's private, or you can ask it now and unmute. So I'm gonna give about a couple of. I'm gonna give a couple of a little brief here, a little brief times. Anybody have any questions? Okay. I'm gonna assume that's a no. If you realize you do have a question, send me an email. Let me know. I'm going to go ahead and end the meeting. Stop share. I'm going to end the meeting for all. If you have a question, send me an email. All right. I'll see you guys on Wednesday.